Now the next question that we are going to see. So before going further, guys, give the heading chapter 6.2 question number 3. It is from March 2017 exam from the booklet chapter 6.2 question 3. So March 2017 exam question 6. So before going further, give this heading, guys. Chapter 6.2 question 3 March 2017 exam question 6, guys. So before going further, please give this heading. Now after giving this heading, try to read this question minimum 2 times, guys. Now try to see the scenario here, what we have to do and how we are going to approach the things, guys. See here we have what? Reverse heat engine. See here we have what? Reverse heat engine. Guys, see, don't worry about this word reverse heat engine. Reverse heat engine is nothing but a what? Refrigerator, guys. Reverse heat engine, guys, nothing but a what? Refrigerator. So this word is only for to make you confused. Oh, how here heat engine comes? Heat engine. So in scientific terms, reverse heat engine means what? Refrigerator, guys. So here we have a refrigerator. So reverse heat engine means what? Refrigerator. So here we have a refrigerator which works on the reverse Carnot cycle. And whenever we have a reverse Carnot cycle, guys, don't worry about anything. Whenever we have a reverse Carnot cycle, don't worry about anything. Our pH and TS diagram will remain constant, guys, like this only. Whenever we have a reverse Carnot cycle, then in that case, guys, what will be? Our pressure enthalpy and temperature entropy diagram will remain constant like this, guys. Getting my point? So for the reverse Carnot cycle, you have to memorize this drawing. So in this case question, they said what? And whether it is a heat engine or heat pump, for both the scenario, we will have the same thing. Here in this case, we have what? In this question number 3, we have what? A refrigerator. We have what? Refrigerator. So refrigerator which works on what? Reverse Carnot cycle. So in that case, our pH and TS diagram will remain same. And what pH and TS diagram will remain same? The diagram we studied while studying the theory, guys. So try to see the scenario here. Very, very important discussion we are doing. So see the things. Now the next point is what? I am going to write down the remaining given things of that question. See, the working fluid is what? R134A. So I am going to write down the names of process is what? So names of refrigerant is what? Refrigerant is what? What is the refrigerant here we have? Refrigerant is what? R134A. And operates between temperature limit, guys. What they are saying? Operates between temperature limits of what? Minus 5 degrees Celsius and 40 degrees Celsius. So this minus 5 degrees Celsius means our low temperature, and this 40 degrees Celsius is what? Our high temperature. So that is nothing but a what? This minus 5 means what? Our saturation temperature at P1. So low temperature means what, guys? What is the meaning of low temperature? Saturation temperature at what? P1 pressure. So T sat at P1 is what? Minus 5 degrees Celsius. And second thing is what? T sat at what? P2. And this T sat at saturation temperature at P2 is how much? 40 degrees Celsius. So instead of giving us pressure, they have given us what? A temperature limits. Means what? This will be our low temperature. So this will be what? Our low temperature. And this will be what, guys? Our high temperature. Try to see the scenario here. So here we have what? Plus, what we can say? Plus 40 degrees Celsius. So here, so from this we will get our P1 pressure, and from here we will get a what? P2 pressure, guys. So now before going further, what we are going to do? We are going to see the property table, guys. Now this is what? A property table for what? R134A. This is a property table for what, guys? Property table for what? R134A. Now our low temperature is what? Minus 5 degrees Celsius. For this minus 5, this saturation temperature minus 5, corresponding pressure is what? For the minus 5, just have a look here. Minus 5, minus 5, oh, here we got a minus 5. Corresponding pressure is what? 2.4335. See this one. 2.4335 guys, observe. So what we are getting guys, corresponding pressure 2.4335. So what we are going to do, P1 is what, 2.4335 unit bar. Then for 40 degrees Celsius, corresponding P2 is what, 40 degrees Celsius guys. For the 40 degrees Celsius, corresponding pressure is what, 10.163. Corresponding pressure is what guys? Corresponding pressure is what? 10 point. Have a look here. Corresponding pressure will be what? 10.163. Observe. So corresponding pressure is what? 10.163. So what we can say here? 10.163 bar. So before going further, please guys write down this discussion. Now, here what they are asking us in the A part, sketch the cycle on temperature entropy diagram. What they are asking us in the A part guys, what we have to do? We have to draw the TS diagram. Okay, what we have to do guys? We have to draw the what? Temperature entropy diagram. So in A part, our target is what? What is our target in A part guys? We have to draw what? Temperature entropy diagram. So now here I am not going to draw the TS diagram guys once again. I am going to copy the drawing that we have drawn earlier and I am going to paste it here. But you have to draw once again this drawing guys, so that you will get a practice guys. So what I am going to do, I am going to copy, because whenever we have what, this reverse Carnot cycle, by default our pH and TS diagram will remain same, that what we have drawn in the theory. So here I am going back to the question guys and I am going to paste that drawing TS diagram. That is what they have asked in the A part. So before going further guys, please draw this temperature entropy diagram. Now after drawing this TS diagram, what we are going to do? We are going to deal with B's first part, B part guys. So first of all, B's first part, what they are asking us in B's first part guys? What we have to calculate? Dryness fraction at the beginning of compression. What is beginning of compression? Beginning of compression means what? Our point number 1. So we have to find out dryness fraction at the beginning of compression. So in B's first part, our target is what? Dryness fraction. How we denote dryness fraction? By X. So we need to find out what? X of what? 0.1. That is what our target. So what we need guys? We need a what? X of what? 0.1. Try to understand the scenario here. What we need? We need a what? X of 0.1. That is X1 we needed. Now for that purpose, we are going to see, just have a look at the drawing. Just have a look at this TS diagram. What is the state of point 2 guys? What is the state of point 2 here? Point 2 is what? What is the state of point 2? Point 2 is what? Dry saturated vapor. What is the state of point 2? State of point 2 is what? Dry saturated vapor. So what we can say? As and at what pressure point 2 we have? At a P2 pressure. So what we can say? S2 is equal to what? Sg. Why Sg? Because state of point 2 is what? Dry saturated vapor. But at what pressure guys? At a P2 pressure. So how much P2 pressure we have? 10.163. P2 pressure we have what? 10.163. So what we are going to do? We will go to the property table and we will go to the what? 10.163. Just have a look at this 10.163 guys. This 10.163, and for that 10.163, for this 10.163, for this 10.163, what we need? Corresponding Sg value. See this Sg value guys, and this Sg value will become how much? Just have a look here. How much value Sg guys we are getting? 1.7109. How much Sg value we are getting? We are getting it what? 1.7109 guys. Try to see the scenario. So Sg value for the 10.163, Sg 1.7109. So we got value of Sg 1.7109. So 1.7109 unit kilojoule per kg. Now then, Here what we can say? Entropy of point 1 is equal to entropy of point 2. So S1 is equal to S2, and this, so S1 will become how much then? 1.7109 kilojoule per kg Kelvin, guys. Here I have written the wrong unit, guys. Unit of entropy must be what? Kilojoule per kg Kelvin, guys. Unit of entropy must be what? Kilojoule per kg Kelvin. So S1 is equal to what? Here we have what? S1 is equal to S2. Now here try to understand the scenario here. So entropy of point 1. Point 1 is at what pressure? P1 pressure. Point 1 is at what? P1 pressure. So first of all, what we are going to do? We are going to find out SF at P1 pressure. SF means what? Entropy of saturated liquid at P1 pressure. And second thing is what? SG at what pressure, guys? Entropy of dry saturated vapor at a P1 pressure, guys. Try to understand the scenario here. So what we are going to do? We are going to the P1 pressure, guys. P1 pressure is how much? How much P1 pressure we have? See the here given things 2.433. So how much P1 pressure we have? P1 pressure 2.4335. So at this P1 pressure 2.4335, that is minus, corresponding to minus 5 degrees Celsius. So SF is how much, guys? This value guys, 0.9754. How much value we have? 0.9754. So corresponding to that value, so SF at P1, how much we have? SF 0.9754. So 0.9754 unit kilojoule per kg Kelvin, guys. Always be careful with the unit. And SG at P1. So we will go to the what? SG at P1. See this one. How much, guys? We are getting 1.7294. How much, guys? 1.7294. So here we will have what? 1.7294 unit kilojoule per kg Kelvin. So we have what? SF at P1. We have what? SG at P1. And with this one, guys, try to understand the scenario here. Now state of point 1 is what? Wet vapor. State of point 1 is what? Wet vapor. And if you remember our discussion from the property table, guys, for wet vapor, what are the relation we can write down for wet vapor? Entropy relation. S is equal to what? SF plus X SG minus SF, guys. This relation we can write down. See this wet vapor relation, guys. S is equal to SF plus X into SG minus SF. So what we are going to do? We are going to come back to our relation. So entropy of point 1. So point 1 is a wet vapor. So entropy of point 1. What relation we can write down? S1 is equal to what? SF plus X. So X of what? Which point? Dryness fraction of which point? Point number 1. So I will say X1 into what? In bracket SG minus SF, guys. SG minus SF. And if you arrange this properly, guys, so X1 will become what? S1 minus SF divided by what? SG minus SF, guys. What is the value of S1 we have? 1.7109. SF value how much we have? Which SF we have to consider? At a P1 pressure, guys. Why P1 pressure? Because the pressure of point 1 is what? A P1. So 1.7109. S1. SF we have to consider at a P1 pressure 0.9754. Then SG is how much? 1.7294 minus 0.9754. Please do the calculation and tell me the value of X1, guys. So 1.7109 minus 0.9754 divided by 1.7294 minus 0.9754. Please do the calculation, guys. And if you do the calculation, dryness fraction of the point 4 we are getting 0.9755. This is the dryness fraction of the point 1 we are getting, guys. So before going further, we have already drawn the TS diagram. After the TS diagram, guys, give the Heating of the part 1, this first part, we need to find out x1, dryness fraction of the refrigerant entering to the evaporator, or dryness fraction at the beginning of compression. x1 we have to find out, and we calculated just now. So before going further, please write down this discussion up to this point, guys. Now after this discussion, write down the remaining discussion, guys. Now we are going to see B second part, guys. What they are asking us in the B second part. Heat removed per kg from the low temperature reservoir, guys. Heat removed per kg. Heat removed per kg from where? From the low temperature reservoir, and that is nothing but a what? Our Q addition, guys. Heat removed per kg from where? See the important relation. Heat removed per kg from where? Heat removed per kg from where, guys? From low temperature reservoir, and that is nothing but a what? Our Q addition, and this Q addition will be equal to what, guys? This Q addition will be equal to what? H1 minus H4. This Q addition will be equal to what? H1 minus H4. So what we will say? We need a what? Heat removed per kg from low temperature reservoir. So that is what? That is nothing but a what? Our Q addition. So in B second part, our target is what? What we have to find out? We have to find out Q addition, guys. And this Q addition will be what? H1 minus H4. This Q addition will be what, guys? This Q addition will be what? H1 minus H4. So what we are going to do? Very simple discussion, guys. Not that much difficult discussion. So first of all, what we are going to do? First of all, we need a what? We need a H1. We need a H4, guys. What we need? We need a H1. We need a H4. Very simple discussion. Don't worry about this discussion, guys. How to get a H1 and H4? We are going to see now. So first of all, we are going to find out H1, and then we are going to find out H4, guys. So first of all, what we are going to do? We will go to the, what is the pressure of point 1, guys? What is the pressure of point 1? P1 pressure. So for the P1 pressure, we are going to find out HF at P1 pressure. Go to the property table, guys, and try to find out HF at what pressure, guys? At a P1 pressure. So go to the property table and try to find out HF at what? P1 pressure, guys. What we are going to find out? HF at what? P1 pressure. So try to see the scenario here. So HF at P1. So HF at P1 is what? P1 pressure is what? 2.4335, guys. HF at P1. So HF at P1 is what? 193.32. How much value we are getting? 193.32. So what I am going to do? I am going to write down this value 193. 1 minute, guys. Let me write down properly. So 193.32 HF at P1 unit kilojoule per kg. Similarly, what we are going to find out? We are going to find out Hg at P1. And Hg at P1, guys, P1 pressure means what? 2.4335. Hg at P1 395.49. How much, guys? 395.49. So 395.49 unit kilojoule per kg. Unit is what? Kilojoule per kg. So H1 will be equal to what, guys? State of point 1 is what? Wet vapor. What is the state of point 1? State of point 1 is what? Wet vapor. So for the wet vapor, guys, we need a what? What is the relation of wet vapor? Of the enthalpy, guys, relation of the wet vapor. If you go to the property table, enthalpy of wet vapor will be what? H is equal to HF plus X, Hg minus HF, guys. And we are going to use this relation, and that's why to use this relation in enthalpy relation, guys, HF plus X, X of which point? X1 point into what? Hg minus HF. And which Hg minus HF we have to use? That just now we find out from the property table. We got it from the property table. So Hg and HF. And why we got it? Why we find out at the P1 pressure, guys? Because pressure of the point 1 is what? A P1 pressure. So here what we are going to do? We are going to put all the values. So HF value is what? 193.32. X1 we just now calculated 0.9755 into Hg 395.49, HF 193.32. So please do the calculation and tell me the value of H1. Guys, please do the calculation and tell me the value of H1, guys. So if you do the calculation, guys, we will get H1 value is what? 390.53, 390.5368 unit kilojoule per kg. So before going further, please write down this discussion, guys. Now what we got it? We got the value of what? H1, guys. Now what we got it? We got the value of H1. With the help of H1, what we are going to do? So we got the value of H1. Now what we need? We need a value of H4, guys. And how to get a H4? H4 is again wet vapor. And for that vapor, we are going to use a similar relation. And for that purpose, we need a water dryness fraction, guys. We need a dryness fraction of the 0.4. Because state of 0.4 is what? A wet vapor. And for that purpose, see the next point, how to get a dryness fraction of the 0.4. And why we need a dryness fraction of the 0.4? To get the enthalpy of 0.4. So first of all, what we are going to do? We are going to find out entropy of 0.3. What is the state of 0.3, guys? Saturated liquid. And for saturated liquid will be what? SF. Entropy of saturated liquid is what? SF, guys. But at what pressure? 0.3 we have. 0.3 at a P2 pressure, guys. This 0.3 is at what pressure? At a P2 pressure. So S3 will be equal to what? SF at P2. S3 will be equal to what? Entropy of 0.3. SF at what pressure? P2 pressure. So S3 will be equal to what? SF at P2. So P2 is what? 10.163, guys. How much P2 pressure we have? 10.163. So we will go to the property table, guys. And at a 10.163, just have a look here. SF at 10.163, how much we are getting? 1.1903. How much, guys? See this one? 1.1903. 1.1903 kilojoule per kg. Now here entropy of 0.4 will be equal to what? S3, and that will become what? 1.1903 kilojoule per kg. Guys, see, entropy of 0.4. See the drawing? Entropy of 0.4 is equal to S3. So S4 will become S3. And 0.4, state of 0.4 is what? What is the state of 0.4? State of 0.4 is what? Wet vapor. And for the wet vapor, we have seen relation. S4 will become what? SF plus X4 into what? SG minus SF, guys. Try to understand this relation. So here, observe. And which SF and SG we have to consider here? Which SF and SG? Which SF and SG we have to consider here, guys? We have to consider SF and SG at what pressure? At a P1 pressure, guys. Because pressure of the 0.4 is what? What is the pressure of What is the pressure of the 0.4? Pressure of the 0.4 is what? A P1. And SF at SG at P1 pressure, we have already got it from the property table. That is what? A 0.9754. So SF at P1 0.9754 and SG at P1 1.7294. We are going to use the same value because the pressure of 0.4 is what? P1 pressure, because 0.4 on the P1 pressure line, guys. See the scenario. So what I am going to do? I am going to S4 value is what? 1.1903. SF value is, guys, tell me what is the value of SF? What will be the value of SF, guys? Tell me the SF value is what? 0.9754. SF at P1 we have to consider. We have to find out X4. And then we need a what? SG. SG is what? 1.7294. SF 0.9754, guys. Check your values. And if you do the calculation, guys, we get the value of what? X4. Please everyone do this calculation. So if you do the calculation, we got the value of x4 is what? 0.285. So before going further, please guys, write down this discussion. We have written already up to h1 guys. After that, write down this discussion of the x4 guys. Now why we got the value of x4 guys? With the help of x4, what we are going to find out? We are going to find out h4. So h4, state of point 4 is what? Wet vapor. And for wet vapor, relation is what? hf plus x means x of 0.4, x4, hg minus what? hf. So h4 will be what? hf is how much guys? How much hf value we will have? hf at what pressure we have to consider? Pressure of the 0.4 is what? A P1. So what? hf and hg we have to consider. hf and hg we have to consider at the P1 pressure. That is 193.32 hf at P1. And hg at P1 is what? 395.41. So hf is how much guys? 193.32. hf is how much? 193.32. x4 0.285. hg, how much hg guys? 395.49. check your values guys, huh? And hf 193.32. So please do the calculation and try to get the value of h4. Please do the calculation and try to get the value of h4. So if you do the calculation guys, we get the value of h4 250.9385 unit kilojoule per kg. So we got the h4. We have already h1 guys. So we need a what? What we need? We need a what? Q addition. And Q addition will be equal to what? What we need guys? Q addition. Q addition will be equal to what? h1 minus h4. So h1 is what? How much h1 we got it? 390.5368. 390.5368 guys, minus h4 250.9385. So please do the calculation and tell me the value of heat addition guys. 390.5368, 390.5368 and 250.9385. So please do the calculation. 390.5368 minus 250.9385. So we will get a what? Q addition? 139. How much Q addition we are getting guys? 139.5983 unit kilojoule per kg. That is what our B's second part answer guys. So if you good with property table guys, automatically this chapter, refrigeration chapter, will become very easy. You don't have to memorize anything, just you have to good with your property table chapter. So before going further guys, we have already written up to x4 guys. See. First of all, we have written up to h1. Then we have written up to what? x4, and after that start writing down this remaining discussion guys. So now what we got it? We got the what? We got the what? Heat addition. Now what they are asking us in this third part guys, heat rejected per kg of a fluid to the high temperature reservoir. So heat rejected per kg to the high temperature reservoir. So that is what the Q rejection they are asking us. In this third part, our target is what? What we have to find out? Q rejection. And Q rejection will be what? Where heat rejection is going to take place? 2 to 3. 2 to 3. So that will be relation is what guys? If you remember our theory guys, important relation. H2 minus H3. So we need a what? We need a H2 and we need a H3. State of point 2 is what? What is the state of point 2? State of point 2 is what? Dry saturated vapor, and pressure is what? P2. So H2 will be what, guys? H2 will be what? Hg at P2 pressure. So go to the property table and try to find out Hg at P2 pressure, guys. P2 pressure is what? 10.163. Hg will become what? 419.41. How much it will become, guys? It will become what? 419.41. So 419.41 unit kilojoule per kg. We got the Hg value. And then H3. State of point 3 is what? What is the state of point 3? Saturated liquid. And for saturated liquid, we know saturated liquid enthalpy is what? HF. But at what pressure? P2 pressure. Because why P2 pressure? Point number 3 is at what? P2 pressure. So H3 will be equal to what? HF at P2. So again we will go to the property table and HF at P2. HF at P2 pressure 10.163 is how much? 256.38. Check once again, guys. How much? 10.163, 256.38. So 256.38 unit kilojoule per kg. So we have H2, we have H3. So relation for the Q rejection, H2 minus H3 will be what? 419.41 minus 256.38, guys. So we will have what? Q rejection, guys. So try to see the scenario here. 419.41 minus 256.38. So if you do the calculation, guys, we will get a what? Q rejection 163.03 unit kilojoule per kg. That is what our B's third part answer, guys. So before going further, please everyone write down this discussion. Now we got it what? Heat rejection. After the heat rejection, what we are going to do? We need a what? What they are asking us? Cycle net work input. What they are asking us, guys? Cycle net work input. So B's fourth part is what? What they are asking us? W net. In B's fourth part, our target is what? We need a what? W net. And what is the relation of W net, guys? W net is what? Q rejection. Q rejection first, guys, minus Q addition. Q rejection we calculated 163.03. Q addition is what? 139.5983. 139.5983. And we will get what? W net, guys. Try to see the scenario here. So 163.03 minus 139.5983. So we will get what? W net 23.4317. Unit will become what? Kilojoule per kg. So guys, please write down this discussion, guys. Now what is our target in B's fifth part, guys? What we have to find out in B's fifth part? Try to understand the scenario here. We have to find out cycle coefficient of performance. And here we have what? Carnot engine, guys. Sorry, Carnot refrigerator. So for Carnot refrigerator, what we have to find out? COP of Carnot refrigerator. So we have to find out COP of refrigerator. But which one? Carnot one. And what relation we will see? We have seen refrigerator. For refrigerator, what is desired effect? To maintain this low temperature. So TL will come into the numerator divided by what? TH minus TL, guys. So how to get the TL means what? Low temperature. TL means what? Low temperature. And that will be what? Tsat at P1. And Tsat at P1 is how much? Minus 5 degrees Celsius. But if we minus 5 degrees Celsius means how much in Kelvin? So minus 5 plus 273, it will become what? 268 Kelvin. So we got a TL. Then after that TH will be what? Tsat at what guys? P2 pressure. Tsat at P2 will be what? 40 degrees Celsius. 40 plus 273 guys. 313 Kelvin. So we will get a what? COP of refrigerator of what? Carnot, and that will be what? 268 divided by what? TL 268, TH 313 minus 268 guys. Try to see the scenario, and if you do the calculation guys, you will get a what? COP of refrigerator. But which one? Carnot one. So please do the calculation. 268 divided by 313 minus 268. So if you do the calculation guys, we get a what? COP of refrigerator, Carnot refrigerator, 5.9556, and unit, as it is a coefficient, no unit guys here. So before going further, we have already written up to W net guys. After W net, this B is fifth part guys.